In this third presentation, I will be discussing the nature of linguistic data and linguistics or cognitive science more broadly. And the best way for me to describe the starting point is to say something like this, namely that our goal or aim is to try to describe and explain human linguistic behavior. So that's the fundamental goal of the whole enterprise. Computational generative grammar, much like linguistics or most branches of linguistics, and also cognitive science that is interested in linguistic behavior. So what I wanted to do in this presentation is just to clarify a few crucial things about this definition and the goal itself. There will be two parts in this presentation. This part one, I will just explain the ideas in more informal and broad sense. And then there will be part two where I will be looking at one particular example. This example is from Finnish language to make everything more concrete. So there are two things in this definition that I want to comment here. The first is the notion of linguistic behavior. And this should be understood in the broadest possible way. In fact, I don't myself try to propose any type of restrictions on this category. Everybody is free to decide for him or herself what is considered to be linguistic behavior. If we go into the linguistic proper first, this includes all the branches: phonetics, phonology, morphology, syntax, semantics, pragmatics, anything. All the methods, all the technical assumptions or technical systems that we will be discussing will apply equally to any of these domains. Doesn't matter. But we will also include psycholinguistic data, which is concerned with the real-time processing or language production, language comprehension, the type of errors and mistakes both speakers and hearers make. Also linguistic explanations that are oriented more towards cognitive psychology, how we use memory resources when comprehending or producing speech, for example. All those things are included. I will also include neurolinguistics, that is questions about where language processing takes place and how it is ultimately implemented by the human neurophysiology and anatomy. That's also included here. It's more about how the linguistic behavior is implemented. Then the linguistic behavior also includes language pathologies. When somebody has difficulties in using language, dyslexia being one example. We will also include sight language and language acquisition. But you get the idea. We will not make any restrictions on this term. And as far as I can see, everything that exists in the current scientific literature concerning linguistic behavior can be, or we can apply these methods I'm going to discuss here, describe in these presentations. We can apply those methods in any such fields. But the more important component here is the restriction into human linguistic behavior. So we are right away excluding things like animal communication, things like artificial languages, mathematical languages, logical languages, computer languages, or even artificial languages that have been designed for human communication. And so those are excluded, but even more relevant is that we exclude imaginary languages, namely linguistic communication systems that we can imagine or that we can think of being possible, at least in theory, but which have not been attested in real world. Linguistic behavior for which we don't have any positive evidence that it has ever occurred or is presently available, or that we have observations of it, or that it could be possible in the future. And this is a very strong and strict requirement for many reasons. One reason is that if we look at most of the engineering models that are available today, when I'm making this video 25, automatic machine translation, large language models that are that implement the type of artificial intelligence systems and so on. These models are uninteresting from our point of view because they don't make this assumption. They are not, their domain is not restricted to human linguistic communication. Machine translators can translate expressions that are not really part of any documented human language. And the artificial intelligence models, the large language models, which operate on the basis of language samples that they extract from the internet and use as they apply machine learning algorithms to text that they fetch from the internet or from other sources. Then those machine learning algorithms can learn almost any kind of communication systems, and they can learn systems which have never been observed or attested in real human communication. For example, if we create an imaginary language from Finnish by reversing every sentence, so instead of going from the beginning to the end, every expression is produced by going from the end to the beginning. Imagine every Finnish sentence, short or long, whatever, in reversed order. The words are in completely reversed order. So that's a language we can imagine, and that's a language that could be in theory possible, but there is no concrete positive evidence that this kind of language has ever existed or exists now or even could exist. But because we don't have positive evidence, we will exclude any model or theory which claims that that's a possible language. And this type of artificial intelligence models, which are simply fetching examples from some source, they are able to learn that type of communication system as well and have maintain conversations in inverted language. And also machine translation systems, if you try to give them expressions in English or in some language which are not attested, they are not grammatical, or the speakers don't accept them, there are errors or mistakes or the word order is wrong, then they will simply translate those expressions. But here, when we are interested in a scientific sense on human behavior, we only accept models where all language patterns which have not been observed, for which we don't have positive evidence, must also be ruled out. I will use these terms attested expression or attested meaning or attested pragmatic pattern when I'm referring to something for which we have positive evidence, and unattested expressions or unattested meanings or pragmatic use patterns when we are talking about something that does not or for which we don't have positive evidence when we are creating the theory or hypothesis. Now this shows that most of the engineering approaches are irrelevant for us, they don't make this type of distinction at all. If they make this distinction, or if they in a later time will do it, then automatically we would be more interested in their properties. But now that's not the case, so we put those aside. The other important and significant implication of this restriction is that we always have to test and verify our theories or hypotheses against both attested expressions and unattested expressions. Because if we are interested in human languages or linguistic behavior, we have to make sure that our theory does not predict the existence of some kind of pattern or behavior that we have no positive evidence of. Translated into a little bit more concrete way still, the data sets that we are going to use for justifying our scientific ideas will have to contain both attested and unattested expressions. Now, actually, I want to clarify now that the term expression, I will be using this term expression not just to refer to expressions as a physical strings or sequences of words or something outer manifestation of language only, of written text on a screen. Rather, the expression will now include also meanings and pragmatical context and all the properties that we might be interested in. I will be talking about surface sentences when I want to specifically refer to expressions, only the surface part. So remember, when I'm talking about something that is attested, I don't mean that that sentence is accepted by some group of speakers. Rather, I mean that we are also including its meaning. What are the possible meanings for that sentence, and what kind of pragmatical conditions exist on its, or restrictions exist on its use. So all of that is always included here. And so going back a little bit, we have to test our theories and hypotheses against both attested expressions and unattested expressions when we include also things like possible meanings and not just sentences themselves. A lot of time linguists talk about grammaticality. I will also be talking about it here. That is a special category of attested expressions, namely expressions, so linguistic patterns can be rejected by native speakers by saying that it's not grammatical, it's ungrammatical. There is some type of syntactic or possibly also morphological error. And this would be contrasted with when the native speakers claim that this sentence is grammatical, but I can't construct what it means, or it sounds gibberish, or I don't understand the concepts in it, or it has words that I don't know. It's a different category of acceptance. Well, here is a picture or some kind of a diagram I draw or sketched about the situation when we go to the level of concrete, more concrete data sets. Let's go briefly through this idea here. First of all, in the right, we will always have a set of expressions in some or several languages in our data sets. So this is, and how to do these data sets will be the topic of subsequent presentations. I think the next presentation is already about how we can do these data sets, so we ignore that part here. But the point is that the data set has to be partitioned or separated. It has to have two classes, two types of expressions. First, we will have unattested expressions, something that doesn't exist in language or real human behavior. And then it will have to have another segment for attested expressions. I will give examples in part 2 of what this will be. And remember the reason, we always have to check that our theory captures this distinction. because the interest is human linguistic behavior and observed behavior, not something that we can imagine but has not been observed. So we have this kind of distinction always in our data set. And then we have another set, namely here in the left we will have the set of expressions that is generated by our hypothesis or theory, or expressions that our hypothesis predicts to be possible, predicts that they should exist, predicts that they should be observed in a real human communication. And this set is also divided into two segments. First of all, we have some almost always some expressions that our hypothesis predicts to be possible, but they are not in our data set. Why? Because the data set is constructed on the basis of what is it that we are interested in. We always have to narrow down a little bit the data set so that it can be used to answer to some more definite research problem. But the theory is usually not limited in this way, so it can always or often predict the existence of expressions that are not in our data set at all. So those are basically put aside. But then some of these expressions must be in our data set. And then what we require is that expressions predicted by our hypothesis or theory coincidence or intersects exactly with the expressions that we attest in the real world and which are in our dataset, this intersection here. If that's not the case, it's intuitively easy to see why the theory would be wrong. It doesn't satisfy the sufficiency condition. For example, imagine that the hypothesis generates also expressions that are unattested. Well, then it's clear that our hypothesis predicts some type of linguistic behavior for which we don't have any concrete evidence. So it's wrong. We have to make corrections. Then it's also possible that it doesn't generate all the attested expressions in our data set. And that also means that there is some behavior in our data or in the real world for which that our hypothesis is not predicting to exist. Again, we see that the sufficiency condition doesn't hold. So we have to keep doing, we have to continue this process until the situation is as I'm describing in this diagram, that these two sets, the intersection has to be exactly like it's shown here. Okay, so that was a kind of how can I say, simplified explanation of how the theory and dataset has to work out. I just wanted to conclude with the first part with making a few comments on some let's say skeptical criticisms that can be presented and sometimes is presented against this model that I just described. This type of skepticism exists also in the scientific literature. So this is not only in my imagination. Now, one of the points that you can make here is that, well, what if the real linguistic data cannot be classified so clearly into something that is attested or non-attested? What if this is more graded or shade or non-binary classification? And you can see this point by noticing that often, if you present the native speakers, examples from some language, sometimes they say that, yeah, this is wrong. I don't accept this. This is not correct English or correct Finnish. Or they can say the word order is wrong here. I don't accept this. And that's like unattested, ungrammatical expression. And sometimes they say, yeah, this is perfect English, I accept that. So it would be attested grammatical. But there are expressions where the speakers are not, they don't really, they can say that, yeah, this is possible, maybe possible, but there's not so good English. I would rather put these words into different order. Doesn't sound right. And so this kind of data can be used to motivate more complex classification. The fact that I presented this distinction so in this type of simplified binary way, this should not be interpreted as a claim that we are restricted to some type of binary classification. No, not at all. If you have data, or let's say that we all come to into agreement that this data really is a little bit fuzzy, the speakers really don't make clear classifications, then there's no problem. It just means that in our data set, we need some way of recording these disagreements or this fuzziness. Perhaps we could rate the acceptability of the expressions by using some kind of scale from 0 to 5 rather than unattested and not attested. So there's no problem. But the problem comes when you will then construct the actual hypothesis or model for a data of this type. Namely, the theory or hypothesis then has to provide an output in terms of the scale that you are using and not in binary classification. So this only makes the situation more complex, but it doesn't change the basic principle in any way. We can predict fuzzy or graded data as much as we can predict more binary data. Now, as I pointed out already in the previous presentation, the way how we solve ultimately this issue is as we together as a community, as all the stakeholders, have to come into agreement of how we quantify, operationalize our data phenomena. And only then, when there is some sort of agreement, perhaps it takes a longer time to come into agreement, we can then create theories and hypotheses for that data. It's a kind of a collective issue. It's not something that I or you or anybody or individual researcher is in a position to settle in any conclusive way. The same goes with the claim that the linguistic or human linguistic behavior is probabilistic. Of course, if it's probabilistic, then your theory or hypothesis will just have to predict probabilistic data. And you will also need to have some way of measuring these probabilities so that I can repeat your observations and acquire same or at least very similar probabilities. There is no, in principle, difference here. I don't myself think that the linguistic data is probabilistic, but if you come to that conclusion, there's no fundamental issue there. You will just have to have a more complex theory that can predict those probabilities, perhaps some kind of numerical data that is added to the data set. But then there is a third comment which is much more important and something for which I will return in a later presentation. And that's the fact that our linguistic behavior when we go from a person to person is not identical. And ultimately, it's trivial that we have speakers who speak different languages. Italian speakers are not the same as Finnish speakers. Their linguistic behavior differs. And so we have to take this into account and find some way of incorporating it into our systems. And the way how I will do this here in a later presentation is that this whole scheme I'm showing here, where we have a distinction between attested and unattested behavior, this will be relativized to groups of speakers. So we will be studying Italian speakers as a separate group from English speakers and Finnish speakers. there is no universal linguistic behavior that everybody satisfies. It's not this observation is really again trivial if you have worked with natural sciences, because even there, when we have some law, let's say a physical law, which describes the behavior of physical systems such as solar system or the orbits of planets or the sun. Actually, the sun doesn't have an interesting orbit, but the orbits of the planets around the sun or the moon around the earth. When we try to predict, when we use the physical laws or principles to predict what happens, it's not enough that we have those principles. We also have to have the initial condition of the system, namely where the planets are at any given time in relation to other planets and the sun. And then we can apply the principles. The same applies here when we are trying to predict human linguistic behavior. We have to take the initial conditions into account when we do these predictions. And here, simply when I'm talking about Finnish speakers and Italian speakers, what we are really saying is that we are talking about two groups of speakers who have been exposed to very different linguistic environments. And that different linguistic environment is the factor which have caused one group to learn a different language than the other group. So the initial conditions are different. This is a simple, when we take the speakers to our experiments in the laboratory, for example, we simply show, or usually we show Finnish examples of Finnish language or Finnish expressions in the experiments for those who are Finnish speakers, and vice versa for Italian speakers. We take the initial conditions, the differences in the initial conditions into account in this sense. But this is a topic of a separate presentation, and it's not trivial. And finally, this argument itself that what I just mentioned here, this simple distinction between attested and unattested human behavior, it's not really that simple. We really have to take the speakers into account. I also come to my mind now that I also want to emphasize that the same argument applies also to things like child language. Young children, they use their native language a bit differently than adults, especially when they're very young, 1 year old, 2 year olds, and so on. The way how we take this into account again is that we will have to relativize this model to the groups of speakers, and in this case to age groups. So when we look what type of expressions are attested in the case of 2-year-old children versus 5-year-old children, we obviously find a huge amount of differences. Again, this diagram has to be used in the context of definite speaker groups. And also language pathologies can be incorporated in the same way. So if we have a dyslexia, for example, then we create a separate model for dyslexic patients or people that have suffered from brain trauma, like Broca's aphasia, for example. Their unattested and attested behaviors differ from normal human behavior, and that will be another group of speakers that we try to incorporate into our model. So you see that this is a quite general framework, but it is something that we have to take into account. Okay, that was what I wanted to state in this presentation. Just to summarize everything, our goal will be to describe and explain human linguistic behavior, where linguistic behavior can incorporate anything that somebody would consider to be linguistic in some sense, involve language, And then we make a restriction that we want to understand human linguistic behavior. And this is where it becomes important to make a distinction between linguistic behavior that is attested and non-attested. And all the hypotheses and theories that we formulate concerning this phenomena, every theory or hypothesis must always be checked against both attested and unattested linguistic patterns or expressions, which then implies that both type of data has to be in the data set. Now, in part 2, I will use an example from Finnish to explain how all this works in the context of more concrete linguistic data.